Hi guys, welcome back to Statistics with Mr. Robeson. Today we're looking at the actual formulas for mean and median and how outliers might affect them. We're going to take a look at percentiles and something called quartiles, and we're going to look at 5-number summaries and introduce box plots. Alright, so I put the definitions in here for you already, so I don't have to try and write them down. But the mean is a measure of center. So when we talk about measure of center, we really have two things we can talk about. We can talk about the mean or we can talk about the median. So when we're doing our cussing, our C, those are the two things you can talk about. I don't want to see the word, the center is this. I want to see the mean is this or the median is this. Usually the median is the easier one to calculate. All right, so the mean is the average. So when you were growing up and you were finding averages most of the time, that was the mean. All right, when you add up all the numbers and divide by the number of data values, that's the mean. I think most of you know how to do this already. All right, the thing that's different with AP statistics is that we have population means, which we use the letter mu for, all right, it's Greek, versus sample means, which we use x with a bar over it, called x bar. We're very creative when it comes to naming. All right, so when I write these, usually my mu looks something like that, and my x bar will look like that, x with a bar over it. All right, so it is kind of an M. It does kind of look like a cursive U, but it is an M. It's a Greek M. All right, so drawbacks of the mean. The mean can be influenced by outliers, and I say Jeff Bezos here, for example. So suppose you want to know the mean, I don't know, net worth of 5 people. So we've got 5 people. And let's take Jeff Bezos as one of them, and he is worth currently $150 billion, the richest man in the world. And then we have 4 other regular people. Let's say that their net worths are each $50,000. All right, and now we want to know what's their average net worth between all 4 of them. So what is their mean? Well, this would be a sample because this is not everybody, but the sample mean here would be roughly, add them all up and divide by 5, since there were 5 values there. All right, and we're going to get roughly $30 billion. All right, now does that seem representative of these 5 people? I mean, if I was in this group, could I say my average net worth is $30 billion? Probably not. All right, because most of the people are right down here at the 50,000 level, and just this one person, this outlier, silly Jeff Bezos, you outlier you, is drawing up the mean by a lot. All right, if we looked at the median here, so the median is the middle number in an ordered list. We got to have the list in order. It is not really influenced by outliers. The middle number would be 50,000. So the median here, which we don't really have a symbol for median, by the way. I mean, there is one thing you can use, but usually we just write median, or we can write med, M-E-D for median. That works too. All right, so let's calculate the mean and the median here for these highway miles per gallon for 20 sampled cars listed below. So if we want to calculate the mean, we're going to add them all and then divide by, let's see, we had 20 cars, so we're going to divide by 20. All right, I'm not going to do that. I've already done that, so I'll show you the answer here in a second. But if you want to add them up and divide, you can see what you get. The median, we want to find the middle number. All right, well, if there's 20 of them, one way we can do this is we take 20, we add 1 to it, so we're finding the middle of the first number and the 20th number, which gives us 21, and we divide by 2, which gives us 10.5. So we want to find where's 10.5. It's going to be between 2 numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it should be between these two. So what we would do is we would take both of these 23s, add them up, divide by 2. Since they're both the same number, you're just going to get that same 23. All right, so there's our mean. It ends up being 22.6. Notice we use X bar because this is a sample. It says sample right here, sample. And our median is 23. So our mean is less than our median, just a little bit. So that means we can say that this data would be skewed. All right, well, it's skewed towards the mean, so it's skewed left. All right, so don't forget that. All right, the other way we can find median is we can just use tick marks, like one below, one above, one below, one above, one below, one above, one below, and we just keep doing this until we get to either no numbers left or one number left. So one below, above, below, above, below, above. We have two numbers left, or no numbers left, so it's between those two numbers. All right, so that works too. All right, so yeah, you could probably find this online. So the mean is heavily influenced by outliers. The median does not care about outliers. Okay, so the mean, big fan of outliers. The median, not so much a fan of outliers. Hopefully that will help you remember. All right, measures of spread. All right, so the range is one measure of spread that we've been using. We're going to be able to get some other ones from quartiles and percentiles. Percentile is really more of a measure of placement than spread. All right, so the range we've looked at before is just the biggest number minus the smallest number. We've been calculating that. Hopefully you know that one. The percentile is the percent of the data that is less than the number. All right, so if you have all this data here, there's like a dot plot of data or something, and we want to know where's the 50th percentile, it'd be right in the middle. 50% would be below it. All right. If we want to know the 100th percentile, that'd be all the way at the top. 100% would be below this guy. The 0 percentile would be down here at the bottom. Right? 0% of the data below it. All right. Most of this we use with normal distributions, and we'll talk about that later. All right. Quartiles. It kind of has the same tiles part as percentiles, and it has this quarter part, which means fourths. All right, so it divides the data into 4 even parts. So I ask this every year, how many lines do you have to draw, or how many cuts do you have to make to separate data into 4 equal parts? And people always say it's 4, and that's not right. So here's our data, this line right here, and if we want to break it into 4 equal parts, what we do first is we break it right down the middle. That's our median. Then we're going to take this bottom half and break it in half, and the top part and break it in half. This we call the first quartile, or Q1. This we call the third quartile, or Q3, which means the median is also referred to as the second quartile. All right, we actually take this and we can turn it into a graph as well. We have the minimum number down here, the maximum number up there, but I'll save that for later. So first quartile is Q1. It's the data value that breaks the bottom 25% off. Then we have another 25%, and we get to Q2. Then we have another 25%, which gets us to Q3. And then we should have a 25% of the data above Q3. So how to find quartiles here? Well, first we need to find that middle number. So our median, it was 23 and 23. I believe it was right between those two. All right, so our median is between them. So that means this 23 is in the bottom half, this 23 is in the top half. So now we want to find the median of the bottom half, the middle here. So we just kind of check off numbers 2 at a time. Bottom and top, bottom and top. It looks like those two are in the middle. We add them up, divide by 2. It looks like we're going to get 18 is right between them. All right, we're going to do the same thing at the top. So we check off 2 at a time. Lowest and highest, highest and lowest. And it looks like we're left with these two here. So our median is going to be right between those. So we add them up, divide by 2, and we're getting 27. So this is our Q1 down here, the 18. Our median right here was 23, which is technically Q2. And then we've got Q3 up here, 27. So 18, 23, and 27. All right, if we want to find, say, the 94th percentile of something, which just popped up here, then we would take our number of data values. So our n here is 20. And we would find 94% of 20. So 94 was 0.94 times 20. Let me type that into my calculator. and we get 18.8. All right, so since we don't have an 18.8 data value, we would say, well, we want at least 94% of the data to be less than this number, so we can't round down. We actually have to round up to 19. So we look to our 19th data value. Right there, 29 would be our 94th percentile. Don't worry too much about percentiles now. We're going to deal with them a lot more when we get to normal distributions. All right, and finally, our 5-number summary. So we just found that, let's see, our Q1 was here, was 18. Our Q2 was between those two, or our median, was 23. And our Q3 was 27. We know that the minimum is 13 and the maximum is 32. When we put these 5 numbers together, this has a name. It's called the 5-number summary. I will often write this with the number 5 in there instead of actually the word. 5-number summary, like that. So the 5-number summary here would be 13, 18, 23, 27, and 32. All right, so now what we want to do is organize this graphically, and the way we organize this graphically is called a box plot. All right, so usually we have a number line down to use for scale. I'm just going to eyeball it, and I'm going to say, okay, my box is going to go from 18 to 27, from Q1 to Q3. So 18 would be here, 27 would be here. At 23, let's see, 23 is going to be closer to the 27. So I'm going to put it a little bit towards this side. And there's our median. It's a line straight up and down in the box, wherever the median would be, 23, because this is 5 units, this is 4 units, so it's a little bit closer to Q3. Should be a straight line. Right. And let's see, our median is going to be our minimum is going to be 5 units down, so about the same length as this. I want to draw a line from here, and my minimum value is 13, so our min goes at the end there. And then on a line up at the top, another 5 units long, and that's going to our maximum value, which in this case is 32. And that's how we draw a box and whisker plot. All right. Sometimes there'll be another dot on here, so sometimes they'll put another dot in like that, and that dot represents the mean. All right. So some people do that, some people don't do that. We usually don't do that, but if you do see that, like a dot towards the middle here, that is the mean. That's what that means. That's what the mean means. I'm funny. All right, so that's it for today. So we went over mean and median. We looked at percentiles and quartiles. We looked at 5-number summaries and box plots. Next time we'll come back with comparing box plots and some more stuff with box plots and outliers. Finally, outliers. All right, see you next time.